Mike?
Podcast?
Yes.
Welcome to Hacking the Grepson, a podcast about programming and software development and ideas therein and related to. Speaking of which, today we're going to talk about the process of abstraction, specifically how it relates to computer science and software engineering. As far as I know, one way to put what abstraction is you have an interface to something, and it could be complicated in the way that you deal with it. For example, I don't know, adding and multiplying some numbers together and storing them in the memory of a computer device. The actual way that that's done on the device is complicated to a human to do right and to do well without messing anything up and causing the machine to die or crash. Which is why we build abstractions on top of that so that you can just, type into a text editor, 2 + 3 × 5 = 15 and set that to variable A and hit save and hit run and boom, it happens. That's the best way I can think of to describe the fundamental concept of abstraction. But I feel like, Matt, you brought this up originally because you had a more specific idea about abstraction in mind. So why don't you tell us what that is?
Yeah, I mean, those are absolutely abstractions, what you just talked about. And in a lot of ways, they are doing exactly what I think good abstraction should do. It's hiding the implementation details from the user because it's not that they're not relevant to them. It's the users of whatever thing that you have built an abstraction around don't need to know the internal details. Perhaps you want to change them. Perhaps they're too complicated, like in the example you just gave, or whatever. So a recent example I had is we were moving between. We just had an episode on version control. We were actually moving between two different version control systems at work over a fairly long period of time due to some complexity. And the first thing I did is originally the code was all talking direct. So our code that I work on actually doesn't just use version control systems like as a version control system. We also access it and read data from it and do a bunch of stuff from like an analytical side of things as part of like the development process to give more information to the developer. So we had a lot of code that was accessing the original source control system just directly, making straight API calls to that. Sometimes those would be in a library, which is also a type of abstraction, but they were still very much like, hey, version control system A, right? All of the logic around it very much followed that flow. It was essentially a one-to-one mapping of how that version control system worked. Now we're going to a new one that works slightly differently. So what I did is I put an abstraction layer, an abstract class actually, in front of our use for it, and I just called it SCM, Source Control Management, same thing as version control. And then I had two subclasses behind the scenes, one to deal with the old one to deal with the new one, and then everyone that used it just went through my abstraction, so that when we did eventually make that switch, I didn't have to change any code. I'd already written both pieces, and all it was now this website that used to give me back this result, give me back this other result, I recognized it, and I would pull in the other file. But from all the code that used it, they didn't have to worry about that because it was abstracted away.
Wow, that's brilliant, Matt. That sounds difficult to do, or at least tedious.
I don't find it tedious. It can be. I find it tedious to do after the fact, right? Like, so what I had to do, I had to go through and rip out all of the existing code and replace it with uses of my abstraction, make sure everything then worked, and then build the implementation for the other system behind the scenes. Designing the abstract class is fairly straightforward. I don't like the part where I have to rip it out. And a big part of why I like abstract classes, and they're very common in like large enterprise level software systems, right? You'll end up with a lot of abstractions, especially the kind that I just mentioned with like your abstract base class and whatnot, specifically because you want to keep those details not hidden from other people, because it's still useful for people to know how things work, or it can be, but keep it out of the right. If I'm writing logic to put a web page up, and go display some pictures in this way, and go pull data from this server so I can put up a map, whatever, right? None of that has anything to do with version control, and the people who are writing that shouldn't have to worry about it. But they may need to go get data from it, and so what I wanted them to do is just say, hey, give me this file, right, as an example. And then I go and deal with the consequence behind the scenes and all the hoops you have to juggle through and the authentication and whatever else. It's very common for libraries are the most common way I think most people deal with abstractions, which is someone wrote a bunch of code and then they're like, here's your interface to it. You use this part. This is how you do the thing. And it's, you've got, could be hundreds of files behind the scenes, but you're dealing with one interface usually, or one class.
Yeah, it seems like a pretty fundamental thing in programming. Like you're always, you can go as far back as saying that all programming languages are abstractions,
even
on
assembly.
top of assembly, which is on top of machine code. Like, it's because, we could all be writing all our software with zeros and ones. Yep. That would be the most hardcore, impossible way to write software. But obviously,
you don't keep a magnetic needle and just poke at your hard drive to write code.
Well, I do.
Okay.
But lesser
I was going to be
programmers can't
disappointed
handle
in
that.
you, Michael.
Right. And I would also be disappointed if that were true, but it's not.
God, that would be a horrible way to write code.
It would, yeah. And the thing is that abstractions are kind of necessary. Although it's funny because in your case, you didn't have to write that abstraction. You could have just forced everybody, or you could have just rewritten all the code that was talking to the old system to talk to the new system and have everybody change wherever they use that, change it to that new, interface or API. So what you did was a really nice bridge to help developers not have to do that.
Yeah, a big part of my job is actually keeping the developers of some product from having to think about things that are outside of that product, right? Let them focus on the features that they're writing. And I just want to make the developer experience better. So, building platforms and whatnot. I enjoy that, and I've had it in bits and pieces throughout my career. It's always the piece that draws me in because I am so easily annoyed by little inconveniences that it's very easy to derail me when I'm writing code. And so I will tend to put abstractions in all the time so I don't have to deal with it for myself. Mm-hmm. And then just making those more generally available and useful has been... it's turned out to be a useful thing for other people, so it makes me happy.
Yeah, no, I like that a lot. What it reminds me of is this phrase on a much more granular level when programming, this idea of syntactic sugar, where there will be a method. I first learned about it in Ruby, but I know lots of programming languages use it, where there will be one form of a function that is easier to read or understand or easier to write or is more quote unquote elegant, that's subjective matter, than another way or a different method. And they call it syntactic sugar and saying that you could do it with this more complicated code, or you could use this other method that was essentially made as an abstraction on top of that because it's easier to understand and use. And you don't have to really understand what it's doing on the inside.
Exactly.
That would be another kind of abstraction, right?
Right. One of the first abstractions I ever, exactly. One of the first abstractions I ever saw, or that I really remember that it explicitly hid the behind the scenes implementation, was in the early days of writing web pages. Right. I wrote them all in a text editor with HTML 1.0, and then they started making these WYSIWYG, right? What you see is what you get editors, where you didn't see the HTML that was being produced. You dragged things onto the screen to look the way you wanted them to look, and it wrote all the HTML behind the scenes. And then a lot of those would let you go in and muck with the actual code behind the scenes. But the first time I saw it, I was like, well, you shouldn't use that because you don't know what's happening, and it's so important to get it exactly right. But the whole point is, if you can make the abstraction do what it needs to do in a more elegant or cleaner way, an easier to use way is the way I like to think about it.
Yeah.
Then it makes it so that the folks using it don't have to know those details, which is, as a very control centered person, I like to have control. It's hard to do that, but technology is very complex, and it advances at rates that no human being can keep up with everything that's going on. No single human being can know everything about, say, software, right? Like when I started, you could know not everything, but pretty close. It's like there weren't that many languages, certainly not in use at the time, and there weren't that many things that computers did because on the cusp of internet days. Now everything does a million different things. The phone in my pocket can do more things than the computers that I had at that time by leaps and bounds.
Yeah.
And so abstracting some of that away allows, it's standing on the shoulders of giants, right? You go in and you're like, I don't have to do this work that's already been done. I could just use that to build this next innovative thing.
Right. It's sort of like, don't reinvent the wheel. Like someone has solved the problem of how to do a thing. I just want to build something more interesting and maybe easier to understand on top of that.
Yeah. And then if you're me, you always reinvent the wheel because you don't like the interface to the wheel.
Right. Well, yeah, that's the problem, is that when you use abstractions, back in the days, you use the idea of writing a web page using a WYSIWYG, like Front Page, I remember, or Dreamweaver. Those were very popular. They were an abstraction on top of what you were actually doing, which on top of what Matt was doing, which was opening up a text editor and typing, less than HTML, greater than, et cetera, until he had a web page. You could do that, but obviously you could be a lot more efficient if you use the abstraction on top of it, and you don't have to understand. Well, and here's the segue, though. You don't have to understand the details underneath, but what happens is this concept of a leaky abstraction, which is my segue into this. I think it's now 2023. Well, it came out in November 11th, 2002. This blog post by a programmer named Joel Spolsky.
It's that old.
It's 22 plus years old. Joel Spolsky is a pretty famous developer in that it was the CEO of Stack Overflow for basically all of 2010 to 2019. He also co-created it with Jeff Atwood, another famous developer. He also created things like the Fog Bugs bug tracker and Trello and probably other things.
He did Trello? I didn't know that.
He did Trello, yeah.
I used to follow Joel Spolsky. He might still do it, send out newsletters. And I used to read those every day, or whenever he sent them out. I would read all of it because I liked his approach to things. So I remember vaguely this article, but tell our listeners and remind me what a leaky abstraction is.
Sure. The quotable part is all non-trivial abstractions, to some degree, are leaky. And what he means by that is basically like if your abstraction is actually being used by anybody and it's doing anything even halfway useful, it's leaky. And what it means by leaky is that, for example, he uses a lot of examples, but and also because this was written 22 years ago, he's using C and C++ as an example for programming. And he's talking about at some point, someone is going to try to add the strings foo and bar, quote foo plus quote bar, and find out that it doesn't work because there's no such thing, at least at the time in C with no extra stuff, as a string class, because all strings are character arrays, pointers to character arrays. And yes, they let you do stuff like string plus string because they want to make it easier to code because strings are ubiquitous and adding them to make a long sentence out of multiple ones is a useful thing to do. But if for some reason it doesn't work, you then have to learn that a string is like an abstraction on top of a pointer to a character array. And so that's the leaky part. The leaky part is that when it doesn't work, when the abstraction doesn't work and breaks in unexpected ways, you are forced to learn the details that are being hidden. He actually opens the blog post by using TCP/IP, which is the protocol that all internet and networks use. TCP, Transfer Control Protocol, is the reliable part, but the IP, the Internet Protocol, is the unreliable part. And so so that's why you always see the TCP/IP, because TCP is being used as the reliable part to control the unreliable IP part. And, it does its best to do that, but when it breaks down, the leakiness of the abstraction becomes apparent, and you have to actually understand how the underlying thing works. So, I mean, it feels kind of like it feels a little downer of an article, like saying, abstractions are inherently broken or inherently brittle, I guess, in that as soon as you start poking at them, you find that they have holes. If things break, it forces people to figure out why they don't work. And so you can't really rely on abstractions if you don't have an underlying foundational knowledge of what they're abstracting.
Or if you know that you're using you're using the case it was written for or whatever, and you're not doing anything tricky. Right. But as soon as you get extra complex with it, you either need to know how it works, or it breaks, or you do what I do and you write your own.
Yeah, exactly. So I mean, like I said, it sounds kind of a downer, but I think it's more just pointing out that it is important to learn how things work and then use an abstraction on top of that makes it a joy to use.
Yes.
I know that all the code that I'm writing eventually will be read by a computer as on and off signals, essentially, but I'm never going to write it that way, right, because that's insane. Sorry, saying it's insane is maybe
it's wild.
It's wild. It's a highly inefficient and maddening way to write software. You could go one step up and do it in assembly. That's still pretty hard because it still requires you to know a lot about how memory and the specific hardware you're using works. What's easy is tapping your finger on an icon on a phone and scrolling and dragging and tapping. That is a great abstraction on top of what your phone is actually doing when you tap it or when you scroll it, And
for the most part, you're not the people who are writing the code that is using that aren't writing code that says detect finger at this location, blah blah blah. There's already an abstraction in the programming language to represent things like buttons and whatnot.
Yeah, exactly. That's part of the language that's created for people to make things for that device, like iOS, Mac OS, Linux, Windows, whatever. The way that you make things to work on those devices have languages and interfaces that are abstractions that are usable and hopefully pleasant and feasible to actually make a thing in. Yeah. But as a developer, it is definitely important to understand that they are abstractions, yes, and that there is something underneath and that there are details. Probably one of the first times that I ever, wrote any kind of software or thought about this is when you're writing OOP code. Yep. When you make a class and you have a property that's often a private property of that class, and then you have a method or a function that acts and mutates that value. You don't actually mutate the property directly necessarily. You use the method because the method can have a bunch of implementation details that you don't need to know about. You just know you need to update the counter in a thing, but you don't need to keep a history of the previous values. Exactly. You don't need to make sure that what you're putting in is not a negative number. It will handle that. And that's the great part about the abstraction of the method versus the property directly.
Yeah, I'm really glad you brought up object-oriented programming because
You always are.
I am. It's there are advantages and disadvantages to all the different paradigms. We have a whole episode about that. Go check it out. But I'm a big fan of object-oriented.
I love that we can say
programming.
that now.
Yeah. We have almost 100. It's kind of nuts. I'm a big proponent of object-oriented programming, and in part, it's because it does make those abstractions so. It's kind of like a first-order principle of object-oriented programming is to abstract away implementation details, right? It's like, yeah, I have a variable. You could modify this variable directly, or I could put getters and setters for that variable, like what you were just describing, and then maybe that variable's not even stored locally. Maybe it's a database that I'm going and accessing, and you don't need to know that. Or you do, but you don't care about what database it's in, right? I can tell you, if you use this library, your data will stay backed up for, it's this reliable. Like, I can make claims because I'm implementing all of the details behind the scenes, but you don't need to know how I'm doing it necessarily unless it doesn't work. When we're doing admin of code, the first thing I do is always figure out how I'm going to abstract the different types of data that we're using into classes so that I don't have to think about them afterwards. It's like, I write the thing, I make it work, I test that class, and then it's done. I don't have to worry about crazy, weird, out of the box type thinking, because I'm just like, okay, this, I have a position class.
You've defined the box.
Yeah. That position class, if I add 2 positions, it, moves appropriately or whatever.
Yeah.
And then in my use of it, I just say, position.add or whatever. And that makes it so much easier to write the what we call, in the industry, you'll tend to call it business logic, right? You've got you have all your infrastructure stuff. But then at some point in time, you have the thing that actually makes your application or whatever. At some point in time, you will have to write the code that actually makes your app unique. Right? What is it that this thing does that other things don't do? Why is this special? Why should I use it? And that's your business logic, right? Google, old school Google, it's the search box and how it does the searching.
Yeah.
And actually, that's a really good abstraction. Back in the day,
That is a great abstraction. Yeah.
you would actually have to go and crawl through different sites to find where things were. Search engines made it so you didn't have to do that. You said, where's a thing that has this keyword in it? And it would find it for you. Great abstraction. I wanted to kind of go through a couple of the different types of abstractions, and we'll come back to object-oriented programming and why it's particularly good for some of it when we get to that point. But, we mentioned a couple already. Programming languages are an abstraction that we're always using, and we don't even think about it most of the times. I have written C++ code that had embedded assembly in it because I needed to do something very specific or very efficiently that you couldn't do in the higher level programming. And even that assembly that's inside the C++ is itself an abstraction on top of the machine code like we talked about.
Nice.
Another place that we'll see it a lot is, how do they refer to it? I think they call it control abstractions, which is kind of similar in the same way, right? Where you're not saying how to do the adding or the dividing or whatever, or a while loop. If you wrote it in Fortran, you're using gotos to control literally the line. If you think about, or basic, right? 10 print hello, 20 go to 10, right? That's a control flow, and even that's an abstraction.
Yeah.
But if you're doing something like a while loop or a for loop, it's even abstracting that concept, because I'm not saying go to this line of my code. I'm saying do this block this many number of times. So the for itself is an abstraction for doing a loop, and then my block of code is the thing to do. There's a bunch of other ones.
Yeah.
Kind of the two I probably use the most are data abstraction, and then abstraction like you would use in object-oriented programming. So data abstraction, I kind of alluded to this earlier when you were talking about getters and setters and accessors and whatnot. Is my data might be in a database.
Right.
I don't want my users to have to write SQL code or whatever to access this data. I want to give them a nice interface. It's like, give me the username Mike, right? And it comes back and it's formatted all nicely and has, whatever method you need to run on a user, right? It's all encompassed there, and no one has to think about it. Instead of, here's the database address, go do a query and a join and all that, right? I
Right.
would never. MongoDB was very popular a handful of years back, and one of the things it advertised was people could just basically do a MongoDB query, like directly. Like your users of your service could just go do that, and I hate that. It's very convenient, but it kicks the can down the road of from a usability perspective. Instead of putting the usability in a simple to use API, now you're like, hey, go learn the MongoDB query language and effectively write code every time you want to access it, which is silly in my mind.
So
a lot of good things about that
quick
database,
aside.
but I don't like that. Yeah.
Yeah, a quick aside before you go on. I have used MongoDB, and I was a little surprised to hear you talk about it that way, because I always thought something like MongoDB was a boon to programmers, because you can use quote unquote programming language like JavaScript basically to query a database, as opposed to having to learn SQL. Or to step back a second, an abstraction that I think you're kind of dancing around is this concept of ORM, which is an object relationship or relation model. And
Yes.
I first ran into that when I started using Ruby on Rails. It might have even been in some like Cake PHP, like framework, where basically they're like, hey, it doesn't matter what kind of database you use. You can use MySQL, you can use Microsoft SQL, you can use SQLite, Postgres, whatever you want. But, Rails has an ORM that abstracts all of their interfaces to like
Classes.
Give me all, classes and methods. Give me users from my app, not, hey, SQLite, give me users from your database structure using SQL. And that was awesome. And that seemed pretty revolutionary at the time, but I feel like that's kind of the abstraction that you're talking about, at least as far as databases go.
I tend to call it a data abstraction layer, but the ORM is the piece of it that you're actually using.
Right.
Even behind the scenes of that, I would probably not have it go straight to a database. I would probably have it hit, like if I'm writing that, I'm going to have a data abstraction layer so that if you switched over from, say, a Postgres database to MySQL, and Ruby does this, right? There's a lot of migrations that have to happen for the database, but you don't need to worry about that in the code. You should just say,
right,
give me my data. I like that concept a lot. And I personally feel that should be used everywhere. I do think MongoDB is great for the programmer who is accessing it. A consequence of the way it is often used is the programmers will say, hey, you know what? I don't want to implement all this query logic and simplify it. I'm just going to give access to pass a query straight through. And I see that almost anywhere I've ever seen anyone using MongoDB, that is a feature that they have added in there. And if it's a supplement, like, oh, this is the advanced way of using it, in wizard mode you would never do this kind of thing, that's fine. And that's actually, I have no problem with that. But where I don't like it is when people are just like, I don't even need to bother with that. Here's access to my database. Go get things. Because then I'm like, well, what's in your database? What's the schema? How do I know where to find things? What's it called? How do I look it up? Right? You have so many more questions. Whereas if you provide someone with an API that simplifies all that, it's gone.
Okay. Yeah, I get you.
Personal preference. I am a big fan of abstractions. I put them in arguably too much. And actually, we should circle back on that before we end this podcast recording of the downsides of abstractions and the complexity they add. But I want to touch on
downsides.
There are downsides to everything, man. Software is just trade-off. Life is trade-offs.
Yeah.
The big place though that people probably see abstractions most directly when writing code and implementing them directly themselves is in defining APIs, interfaces, and abstract base classes, right? It's all of those things are the way that you are saying, here's how you access my system.
Right.
Abstract base classes are cool for this because if you have multiple ways that things might be implemented, in particular, they're great. So you will have your base class that you're like, these are the functions that you can call on every, I don't know, pet or car class, whatever thing. There's a bunch of different types of behind the scenes. You can call, we'll stick with cars. You can call drive, you can call number of doors, you can check the number of tires, you can, see how many seats are in there, whatever, right? There's a common thing.
Check the gas level or the charge
Well, see,
level.
I would,
Yeah.
energy level, maybe. That's the thing. If you were abstracting cars away 20 years ago, you wouldn't have to think about electric vehicles. You'd say, what's the gas level?
Yeah.
But now, if you were going to do it, well, maybe you're driving an electric vehicle. Maybe you have a hybrid. The information you need is maybe different. So what you would
Very
probably
true.
do there is not put that in the base class. You'd have that down a level lower. And where I like abstractions in object-oriented programming is the concept of an abstract class, where you might implement some of the functions, but ultimately you have some methods that are not implemented in your base class, and you're saying the subclass must implement it in order to be used. Like you can't instantiate the Ford car variable until or the Ford car subclass until it's been written to implement one of those functions, like get logo or whatever. I don't know what's different about a Ford than other things.
Truck bed size or something. I don't know.
Number of wheels, right? Whatever. Any of those things. And so an abstract class is really nice because it gives you that interface and tells you, here's the thing that you, as the creator of the implementation, have to do in order for the base class to work. And I use this a lot, going back to the SCM thing that we talked about earlier. Some of my functions were calling other abstract functions inside that class. So like if I knew that I wanted to simplify, there was a common thing you needed to do with like checking in, right? Maybe it's multiple steps. I would have abstract methods for the individual steps, but then I would write the logic side of it not as an abstract in the base class. It's like, okay, call this method, then this method, then this method kind of thing. That's the template pattern, if any of you are Gang of Four fans. In which case, why are you listening to this podcast? It's great. Tell us what you think. But yeah, that kind of thing is used all over the place. Some other places besides data abstraction that we talked about that you might see it are the concept of an abstraction layer, which is quite common if you're doing client-server programming or any sort of distributed system or anything that's particularly complex. You'll often see this like on like web apps. Actually, you'll often see abstraction layers just to separate out. It's like especially back in the days when the browsers were not consistent with how they would implement things, there would be levels of abstraction for calling the actual implementation in Internet Explorer versus Netscape Navigator or whatever.
Right.
Those are very useful. That's just another way of doing an abstraction, but layers are very common, layered architectures.
Oh, like in the OSI model of like networking?
Yeah.
The OSI, like physical network, et cetera. I don't remember. There's like 7 layers of it.
Exactly. Yeah, and separation of concerns is a big advantage of using abstraction layers. It's like, okay, this layer is responsible for doing these things, and it's going to talk to something that can do network communication. But I don't know how you're doing the network communication. For all I know, you're printing it, you're writing it to a disk and walking it across the office and putting it in. I don't care. The point is the data gets over there.
I mean, that's how we do it, for sure. Yeah.
Yeah, sneakernet, right? There's a ton of those things. There's a lot of advantages to using abstractions, but there are disadvantages.
Disadvantages, such as what?
Anytime you're doing anything like this, you're adding complexity, right? And adding complexity to a system is inherently making the software more complex by definition, right? And that comes with its own set of risks. It's more things you have to test. It's more stuff you have to maintain. If you're in a typed language, often you will have created some type to represent data behind the scenes, and you have to propagate that up into your abstraction level as well so that the folks using it can see it. And so that can get complex. Now you're maybe like, you want to change the method of something. Now you have to change it in two places. And so like the function signature, you want to add a parameter. Now you have to do it in two places. You have to do it in the abstraction and in the implementation. And that can get irritating. It adds overhead. So there's, the developer cost of the people writing it. There's the maintenance cost of it. There's the time you're spending up front to add an abstraction. There's the leaky abstraction concepts that Joel Spolsky talked about, which is a lot of those just go hand in hand. And so it's and those trade-offs, or the trade-off there is it worth my users of my product having an easier time, a simpler time to use my product for me to spend more time adding an abstraction? For me, yes. For some people, no. And often what you'll want to do is not have the abstraction in, work really fast, get something working, and then add in the abstraction. That is the way a lot of people like to work. I tend to work the other way, but different strokes.
I mean, have you ever created an abstraction that was either like then later taken away or maybe just not used in the way you thought? Like it didn't go over well?
I have certainly had them go away. In particular, with a situation like the SCM migration that we were talking about earlier. After the migration, do you still need the abstraction? Because now you're just talking to this. Now there's only one option for where you're talking. And there's an argument to be made on either side. On one hand, you can get rid of that abstraction layer and simplify the use of it. And you still have your class, so people are calling this directly. But if you ever did need to do another migration to another type of database, you're making a choice now to be able to move faster with implementing new features using this new, thing you move to at the cost of future maintenance for this product. If something changes 10 years down the line, now you have to do the same thing that you did 10 years ago with an abstraction. And that happens all the time when people want to get rid of the abstraction for that. I have proposed abstraction layers in my role as like an architect. And I'm like, we should break the product up like this. And have been met with absolutely not. We're not going to do that. It makes it too hard to write the code. And there's justification of that. If you don't have enough people to maintain the code with an abstraction layer, then maybe you don't write it. And if your goal is to move quickly, maybe you don't do it the right way with an abstraction layer, and you just get it done. So there's pros and cons to all of it. But I've certainly had my desire for abstractions questioned and straight up ignored.
Yeah, I mean, I'm thinking of stuff like, a programming language or a framework or a library or, enterprise software. Those kinds of things like almost are required to use abstractions for these kinds of things because they're meant to be used with a variety of things, and you don't know what it's going to write to. Like, your framework could be used with various database systems. You can't just write your framework and it only talks to MySQL and nothing else. And if you want it to talk to anything else, you have to write that adapter yourself. I mean, people will probably do it if it's popular enough, but I mean, it definitely, you probably assume that it's going to be able to talk to like the top 3 or 5 most popular database systems. Or if you're making something that uses version control but allows you to use your choice of version control, it probably has an abstraction or an adapter that works with the top popular ones and maybe not the less popular ones. If you want it to work with some real niche thing, then you have to write that abstraction or that adapter. So
exactly.
Yeah, but if you're just like writing something for your company that's used internally, you definitely probably have to have more of a discussion, and there's way more pros and cons about going the abstraction route for something like that.
What's the expression? It's like it's quick, good, and cheap, I think. And it's like pick two.
You have 2 of those,
yeah.
Right?
So often that's where the decision not to use an abstraction will come in, because cheap and quick tends to outweigh good in most people's minds.
Well, because good enough is often will win over good.
Right. Yep. Because good is dumb. Ridiculous.
But my Schwartz is big.
You asked earlier, like, have I ever experienced people going around the APIs? And I mentioned a couple examples. Probably the most common place that I've seen that happen, not necessarily my abstractions, but abstractions in general is specifically the data one. Someone will put ORM in place, or they'll have like a data access layer server, so you hit that instead of the database. And I have many times in my career seen people just go around that and go straight to the database. You know, the clients often will be like, well, I can do this more efficiently. And I'm like, okay, but if you do that and I decide later to change the database, that's your problem. And they have to recognize that. Except what usually happens there is they're like, well, this is the way it's done now, so you have to support it. And that's its own bag of misery.
Bag of misery. Wow, I love that phrase. That can be used for so many different things. I was just looking at some of the other examples that Wikipedia has about this, and wrapper libraries and wrapper functions and shims. I've seen that a lot in, for example, there's a program called RBENV, which is like Ruby environment, which is basically like, hey, I want to have multiple versions of Ruby, and I want to be able to switch between them. And each version of Ruby can have its own set of Ruby gems, which are basically their plugins. And those could have their own versions inside of each version of Ruby. And so when you switch between versions of Ruby using RBENV, it creates shims that are basically just kind of like pointers to whatever the specific version of Ruby and specific version of the Ruby gem you're using. So you don't need to know that it's doing that. You just run the command and it does all of the translating in the background. That seems like a very common thing that developers see when they're using lots of libraries that have different versions. And, you know, like it's kind of a form of like a symlink, which, if you use NPM, or I use PNPM.
If you're using NVM for your version management, it does the same thing.
Yes.
PyEnv, virtual env on Python side of things, similar concept. It's a very useful one. And there are also people who do not want to use that because it hides the specific. And if you want that level of control, and you're like, no, I'm going to install this version of Node, and I'm going to install this version of NPM, I'm going to install this, and I want it in this location. Right, people will just bypass those products. But me personally, I don't want that level. I don't need that level of control. I want my programming language to just work in my mind. So I want those virtual environments so that I can say, okay, well, I need Python 3 over here and Python 2 over there. Or I don't need to install every single one of these packages globally. It gets installed to this local one.
Right, because I mean, as a developer, I'm trying to develop a thing. And what do I need to develop my thing? Oh, I need to check it in the programming language it's being written in, but there's multiple ones. So I need to check it in both of them, or three of them, or four of them, because I need to make sure that my application is good up to the last like 5 releases of that programming language or whatever. And whatever tool is going to abstract that complexity away so that I can do what I need to do, which is write the program, not micromanage my programming versions on my computer.
Exactly.
We talked about containers before. Docker. I can't believe we didn't mention Docker is a huge abstraction. Like you're basically running a whole OS and it's various components, system components, and a programming language and a database, and it's all sitting in a quote unquote container, which is a huge abstraction of
they abstracted away the need to install the operating system on your actual hard drive. It's now stored in this image somewhere, and you just pull it down. It abstracts away the entire bootstrapping of a computer, which is fantastic,
amazing.
And that's one of the reasons I really like Lambda functions in AWS is I'm like, I don't need to set up my development environment to run them. It just exists. I'm saying, give me a Python 3 environment, run this function. It gets rid of all of the extra noise that I might need, that you might need to spin up your own service. It's like, well, it's just there. I just do this thing. And now I had to focus on writing the piece that did the work and not wasting all of my time setting up my infrastructure.
Yeah. It's like that old quote from Carl Sagan. Like, I want to bake an apple pie. And I know I need to first invent the universe, but I'd rather not do that. I'd rather abstract that away and just make the apple pie.
Exactly. And that's why abstractions are good, because you get to eat apple pie.
Exactly. And I think that's a wonderful place to end our episode. Go have some apple pie and make some abstractions. But until you get around to doing that, I just want to let you know that this is the end of our episode of Hacking the Grepson. Thank you for listening. We have more episodes of this informative and handsome
Highly
podcast
entertaining.
on hacking. Highly entertaining, informative, witty, gorgeous podcast on hackingthegrepson.com. We try to put out one of these collections of audio bits between Mike and Matt and sometimes other people every other Wednesday for your listening pleasure. But until the next one, we now return you to your regularly scheduled lives already in progress.